All right, so everyone's favorite song we just experienced. I am a parallelogram, right? All right. If you don't know what it is, look it up. We are going to start quadrilateral notes. Looks like this right here. And just a reminder, the very last page is like kind of a key of all the properties of all the different quadrilaterals. Okay? So we're going to start with, on the front page, the first one, which is square. Now, hopefully you know what a square looks like, and hopefully you know what these properties are, but if not, it's all right. So we're going to drop down here to the properties. All the sides of a square are, and here's our what do you call it? Word bank. All the sides of a square are congruent. Okay, so we'll write that, and we will label that. Okay. Wow, I just noticed this. Do y'all see the typo? Yeah. Okay. All angels. All these angels. Just kidding. All right, so, but all angles of a square are right, okay? Now, we can measure that, and we'll do that in a second to verify this, but, okay, all the angles of a square are congruent, and they're right. So we're going to actually we're going to say right angles. And opposite sides of a square are parallel. Good. So parallel, how do we notate that? With little arrowheads. So check it out. Arrowhead, arrowhead, two arrowheads, two arrowheads. Okay? Now, we'll come right back to this, but we want to measure so we can fill in these blanks. So hold your horses on this, okay? So if I were to measure this using my trusty protractor, okay? Oh, whoops, I froze it. Lamp. Oh, there we go. All right, so if I were to measure this, okay, and if I were to extend this line, I would see that it's 90 degrees. You can't see that. There it is, 90 degrees. Okay? So we're going to write that in for these four angles, because remember, they're all the same. 90 degrees, 90 degrees, 90 degrees, 90 degrees. I should. And then we're going to measure AB, BC, all that good stuff. So, there we go. So for AB, now it's close to 2. You know, we'll just give it the round here. So it's about 2 inches. Cool. So let's write that in. And all the way around, the property of a square. Okay, we're going to kind of cut to the chase on these notes, but 2 inches all the way around. Okay. So, can I borrow this for a little bit? Okay, so that's square. So from now on, when I say square, you got to know these things, okay? All the angles are right. All the sides are equal. 2 pairs of parallel sides. That's what makes it a square, okay? So let's go down to my favorite, a parallelogram.
Wait, hold on, I didn't get those.
So make sure you stay on my pace, you know what I'm saying? So for parallelogram, we're going to measure these angles. So angle J, let's measure angle J real quick. Yo. It's funny. So in my angle J, it's pretty close to 120 degrees, so we'll go with that, okay? So 120, and then angle K, if I were to measure, I'll go this way, angle K, it's going to be not 120 since it's acute, it's going to be 60, okay? And then spoiler alert, L and M will be 120 and 60. So we're going to write that on the smartboard file, okay? Not that. Where am I at? All right. 120, 60, 120, and 60. Okay? So I still take my protractor and I'm going to measure JK, KL, So JK from here to here. Okay, it's not a perfectly nice number, but it is what it is. So 1, 2, 3, 8. 2 3/8. Okay, so we'll give it a little round here. So 2.4, we'll go with that. And spoiler alert, ML is also going to be the same, about 2.4. And let's look at KL. So KL. Okay, it's about 5/8. Okay, so maybe about 1.7. Let's write that down. And it's going to be the same for both of these missing side links. So, from what we just measured, we see that the opposite sides are congruent. Those opposite sides of a parallelogram are congruent. And just by looking at it, we can see that they are parallel. The name kind of tells you, parallel. So we'll label that, opposite sides are parallel. Okay. The second one, opposite angles are what? So again, look at these opposite angles. They are congruent. Okay. And then consecutive angles of a parallelogram are, so I want you to notice, opposite angles, one arc, opposite angles, two arc. But I hope you notice angle L and angle K are called consecutive angles. Okay, in the song that we just heard, it's adjacent angles add up to be 180 degrees. Now, what do you call it when they add up to 180 degrees? What's the fancy word for that? Supplementary. Y'all know that? So guess what? If it's a parallelogram, those consecutive or adjacent angles are supplementary. They add up to 180. Supplementary. Okay? So that's the first page. If you finish writing that down, you can turn it over to the second page, where we're going to talk about a rectangle. Rectangle. All right, so on a rectangle, so we go to the picture, and we're going to measure some stuff here. So, all right, so when I measure, let's start with EF. Okay, so real quick, these angles, they look 90. Let's just make sure they are. It's 90. It's 90. Okay, so all these angles, 90, 90, 90, 90. And then EF, let's measure these real quick. It's about 3.5. Same thing for the bottom, 3.5. And then on the sides, it's about 1.75. Okay, so let's write it on the smart file. Ooh, don't do that. All right, so these are all 90, right? So to fill in these blanks, so let's get some crowd participation, crowdsourcing. All angles of a rectangle are what? They're congruent, and they are 90. They are right angles, right? So they are congruent. That's true, but specifically they're right angles. And what do we know about the opposite sides? They are parallel, and, well, the side links that we connected right here are what? Congruent. They're the same, right? When we talk about supplementary, we're talking about angles. So these are sides. Now let's label this. So all those right angles, label those. And then the opposite sides are parallel and congruent. Parallel and a different congruent. Okay, so there's our rectangle. So far we've talked about square, parallelogram, dab, and rectangle. Now, we get down here to rhombus. Now, when you look at a rhombus with your head tilted, what would you actually call that?
A diamond.
Okay, so a lot of people call it a quote-unquote diamond, but we call it a rhombus, okay? So, let's measure this stuff again. Boop. Rhombus. If I can pick this up. All right, cool. All right, so on my rhombus, I'll line everything up. It's about 60 degrees for angle P. Okay, angle N is also 60 degrees. Angle O, if it's supplementary, it's going to be 180. Or sorry, 120. And it is 120. Look at that. Okay. So, bet the other one is 2. Oh, yes, it is. It's 120. All right, so, and then we want to measure these side links. Okay, so this is about 2.5, let's say 2.4. And then this one, oh, it's about 2.4. And it's about 2.4. And it's about 2.4. Oh my gosh. So we're going to fill that in on the smart file here. Hello. All right. All right, so that's our rhombus, and we're going to label that after we get to this part. So all sides of a rhombus are what?
Equal.
Okay, they're all congruent. Okay, so the sides are congruent. Okay, all sides. Now I'd say, if you wanted to say parallel, they're not all parallel to each other, but they do have two sets of parallel pairs. Opposite angles of a rhombus, so opposite angles are, once again, congruent. Okay. Remember, only sides can be parallel, so angles are either congruent or supplementary. So in this case, opposites are congruent, but look at the next one. Consecutive angles. Okay, so here, this is what I mean by consecutive angle. Angle Q and angle P. Obtuse, acute. Together, they would make a straight line. What's that word? Supplementary. Right? So let's label everything here. All sides are congruent. Opposite angles are congruent. Okay. Technically, we should put some parallels on here. Okay. Doesn't work unless it's parallel. All right, so that's a rhombus. That leaves us with one more, a kite. And that's a lie. Two more, a kite and a trapezoid. Sorry. One more page is what I should have said. All right. You got punked, lol. All right. So, we will discover the difference between a rhombus and a kite right now on this episode of Notes. All right, so let's take a look at this so we can measure our kite. And hopefully you know what a kite looks like, IRL. It looks just like a kite in geometry, right? So, take the pass. So, angle R, let's do this. Now, I'm going to have to extend this line so I can actually measure this. So I do that. And this is not going to be a nice, pretty one like I want, but it is what it is, okay? So this is about 1/16, okay? So angle R, we're going to put 1/16. Okay, it's angle S. Okay, angle S is about 90, if I'm seeing that right. Looks like it. That means angle U will probably be the same. Okay, yep. So U and S were both 90, and then angle T, okay, it's right up here at 64, okay? If we were to extend that line, it'd be a little easier to see, okay? So 116, 90, 64, 90. RS, get on that measure right here. We got about 1.4. Over here, we have about the same thing, so about 1.4. And then over here, it's about 2.25, 2.25. And guess what? 2.25. All right? So 1.4, 1.4, 2.25, 2.25. All right? So let's write that down on our smart book file. Okay, so 116.90, 64.90, okay? So that means that these are equal to each other. They're not always 90, but they are equal to each other, okay? So we had 1.4, 2.25, 2.25, 1.4, okay? So these are rough estimates sometimes. So the question was, what's the difference between a rhombus and a kite? Is everyone still with me? So a kite has two pairs of consecutive sides that are what? So I want you to notice this and this. Those were equal. And then this and this, those were equal. Okay? So instead of having opposite sides that are the same, it's consecutive sides that are the same. Okay? That are congruent. That's what makes it a kite. Two equal sides next to each other, two different equal sides next to each other, with two opposite equal angles. Okay? So consecutive sides that are congruent is the word there. And a kite has one pair of opposite angles. So again, like we said, U and S that are congruent. Okay? So to answer your question in the back about the difference between a rhombus and a rhombus would have opposite equal sides, but a kite has consecutive equal sides. That's the big difference. And also one flies in the sky. Kind of cool. Alright, and then trapezoid, okay? For some reason, trapezoid always reminds me of Pizza Hut. I guess because they used to kind of have like a logo that kind of had like a trapezoid in it. It was like Pizza Hut. Alright, wait, Miss Morrow.
A trapezoid reminds me of the circus. When an elephant stomps on the little footrest and puts its foot on there, that's a trapezoid.
All right. So actually, I'm looking at the Pizza Hut logo. It looks nothing like a trapezoid, because you'll see here. Yeah, I mean, kind of, but not really. So, anyways, don't think of Pizza Hut. I'm not teaching you that. I'm telling you that's wrong. Okay? Am I gonna get you pizza? Find out next time. Come to class on time. Who wants free hundreds and free pizza, and you never have to go to school? Cool. Hey, that's good. You don't want to be a bum. Good. All right. So none of these are promises. Well, we can dream on a Friday, right? So trapezoid, though, for real. Let's measure this stuff. And if I can hit the right button, here we are. All right. So trapezoid. All right. So angle W. If you line it up right here, we got 90. Okay. Same thing probably here down here with Z. Yep. And then angle Y. We'll go this way actually. Angle Y. It's about 65. And then Z. It's about 115. Okay. WX. Get that measure. It's about 2.8. Just to get an estimate here. XY is about 2.7. Why not? ZY is about 3.6. These are rough estimates right here. And then 1.5. Okay. So we'll take that. We'll fill it in on this file. If I can get rid of the stuff I don't need. Here we go. All right. So we had, what, 90, 90, 65, 115. We had 2.8. These were not equal right here on purpose. 3.6, 3.6, 1.5. Okay, so the only thing we really see about this trapezoid that we can definitely define is that it has one pair of opposite sides that are parallel. They're not congruent. The only thing I know is that this and this are parallel, and that's it. The side lengths can be different. They can stretch them out. It's whatever, okay? Now, if you look at the very bottom, okay, let's just get out of your system. Theorem 6-6/6, okay? Ha, 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 ha. Okay, so we're over it now. Trapezoid mid-segment theorem. Okay, so what is a mid-segment? If you take a midpoint to a midpoint, that's called a mid-segment. Now, let me make this super easy. To find a mid-segment, all you do is take that number and that number, add them up, and divide by 2. It's what we call taking an average. You just average out the sides to get the mid-segment. Okay? So let's do this example real quick. I have a trapezoid. I see 9 and 5 as my parallel sides. So I think 9 plus 5 divided by 2. So that's what? 14 divided by 2. That's what? 7. 7 is exactly between the numbers 5 and 9. That's how you do mid-segment. Next class period, we're for sure going to go over how you do that, but all the properties that we've covered today are going to be applied when we do the assignment on Monday, okay? So don't lose this, because this is going to be referenced, okay? And we're going to spend the rest of this class period listening to I Am a Parallelogram, because we love it so much, all right?